And welcome. I know, having related rates and then coming right into some more rules, it's hardcore stuff. We can do this. All right. So this next one, we need to remember a couple of things. All right. That the derivative of e to the x is e to the x, and the derivative of a to the x is the natural log of a times a to the x. Okay. So we'll remember those things, and let's go on to what our new rule is. Our new rule is regarding natural log of u, okay, where u is any function, okay. So what that means is that derivative is going to be 1 over that function times the derivative of that function, because it's just an extension of the chain rule. All right. So a for instance is if I have ln of t squared plus 1, and that's my y. Now I want to go ahead and find dy dx, or t, dy dt in this case. And I say dy dt is equal to a natural log of a function. All right, so that means it's going to be 1 over that function, t squared plus 1, times the derivative of that function. Again, a chain rule, okay, of 2t, which is then going to be equal to 2t over t squared plus 1. Okay? All right. So that's the extent of basically what this is going to be. We have one more rule to do, but the question is let's see how we can start using some of this new knowledge, okay, or some knowledge in general, to create a more interesting problem. Okay, we've always been asked in the past, hey, here's a point, find me the slope of the tangent line, find me the equation of the tangent line. But in this one it says a line with a slope m. So my slope here is m. That's my slope of that line. Passes through the origin and is tangent to ln of x. What is the value of m? Whoa. So this is where we have to realize, hey, you know what? We have a couple of different ways to find this slope. Okay? So first way, the way we've all been thinking of, okay, is, hey, you know what? Here's this point here. I'm going to call it A. You know what? I can find that slope. Okay? So let's go find that slope at point A. We're going to say it's sum A. All right? So I can do that. So I come over here and I'm going to find out that dy dx, I take the derivative of ln of x, is equal to 1 over x. Oh, okay. Well, that means at that slope, so that means my slope is equal to 1 over a. All right, great. So that doesn't really help a whole lot. I still don't know what a is. I need to find that out. I wonder if there's another way I can find slope of this line right here. Well, I know that it passes through the origin and it passes through this point a comma, well, what is this? ln of a. Oh. So if I do my good old-fashioned slope formula, y2 minus y1, I can also say that the slope of that line is ln of a minus 0 over x2 minus x1, a minus 0, which is then equal to the ln of a over a. Well, now I got an equation, right? Because both of them are supposed to equal the same thing. So I know that the ln of a over a is supposed to equal 1 over a. I multiply both sides by 1, or a, excuse me, and I get ln of a is equal to 1. Now we have to go back to pre-calculus. We have to remember, how do I solve a natural log problem? Oh, right. I'm supposed to raise each one to the power of e. When I do that, e to the ln of a, e to the 1, e to the ln of anything, okay, this is what you have to remember, e to the ln of whatever is always going to be that whatever. Is equal to e to the 1 is equal to e. And there it is. A is equal to E, which means my slope that I was looking for is equal to 1 over E. And there we go. Pretty cool, right? So besides the E to the anything, okay, is that you need to know that the other rule that you need to know, or remember for your homework, is that the ln of E to the anything, let's say 3x, okay, is equal to that anything. That's just a definition of logs, okay? That'll help you out. So the two rules you should know is that rule, and the other rule that you should know is that this one down here. E to the ln of anything is that anything, okay? All right, let's see what our next rule is. All right, so for our next rule, this is general logs of base anything. I'll be honest with you, I've seen maybe 2 problems on AP exams on this. It's not a hugely tested item, but it was something that is covered, and we do need to make sure we know it, okay? And so, again, let's take a look at an example of this. So if I were to do like a problem and I say that y is equal to log base 4 of, I don't know, 6x plus 2. So what it's telling me to do, to find dy dx, or my derivative y prime, is to take 1 over u. Well, what's u? U is my function, 6x plus 2, times ln of a is my base, so ln of 4, times, okay, again, chain rule, derivative of my function, which is 6, which is then all going to be equal to 6 over ln of 4 times 6x plus 2. Alright, so then how is this applied? What type of application could I have for this? Okay, so this is like the chain rule on drugs, right? Alright, so I have a log with a function. So there's one function inside of a function inside of a function. So log of a function of a function. So this is like a peanut M&M. So they want me to find dy dx. Okay, so dy dx is equal to, okay, derivative of log is 1 over whatever function I have there, a to the sine x times natural log of my base, in this case a, times derivative of the function, derivative of a to the sine x. Again, remember recall. Okay, the recall part has the natural log of a times a to the sine x times the derivative of sine, cosine of x. Whew. So now if you may have noticed, all this timesing with this dividing, the ln of a's will cancel out, the a to the sine x's cancel out, and all I get left over is cosine of x, which is kind of cool. Alright, well, that's about it. Okay, you got to remember the logs and chain rules and all that. Not too much into this one. Here are some examples and problems. Please take time to do this. Okay, our 6 weeks exam is coming up quickly. You need to be able to have this taken care of, and I will look forward to your questions next time we meet. All right, bye.